So welcome to Academia. My name is Brian, and in this video we are going to talk about unique and one-sided limits. All right, so this video will definitely act as a recap to most of you, considering that this concept we've introduced it in some of the previous videos, but it is important that we know. Now, I want to write here that if you have a limit as x approaches a from the positive direction of f of x, this one is known as a right-handed limit, okay? Right-handed limit. So it's a right-handed limit. I can abbreviate this as right-handed limit, RHL, all right? So what it means is that if this is a, all right, this limit is moving this way, all right? Are you together? So it's coming from this other side, yeah? The right-hand side. So right-handed limit is on this side, yeah? And this positive means that it doesn't mean that A is positive, okay? It means that we are moving towards the right, okay? So A is taken as the reference point, but we are looking at values that are towards its right. So A can be 3, A can be 0, A can be whatever number A is. Right? So it doesn't mean that you have a positive number or a negative number. It can be either. Okay? Such that you can also have something like limit as x approaches minus 3 from the positive direction, something of that kind. Yeah? So this one shows that positive 3 is the reference, negative 3 I mean, but we are considering values that are from this right-hand side. All right? Yeah. And similarly, we have left-handed limits, which is limit as x approaches a, this way, of f of x. This one is a left-handed limit, all right? And now, if the left-handed limit is not equal to the right-handed limit, then we say the function f of x, all right, has a one-sided limit. So one-sided limits. All right, so that is the condition. All right, so and we are going to have an example, two examples here. We are going to have one example. Don't know how many examples I should give you. Let me give you one example and one exercise. So we have a question here that is saying, show whether the following limits have unique or are one-sided, all right, limits. So if this is okay, if this is upheld, that the left-hand side limit is equal to the right-hand side limit, we usually say that the function has a unique limit. So LHL, if LHL is equals to RHL, then the function f of x has a unique limit, has a unique limit. Don't worry about man writing. I mean, it's mathematics. So the example here, you're told, show that limit as x approaches negative 3 of f of x, show whether the following limit has show whether the following function has a unique limit or a one-sided limit. So limit as x approaches 3 of f of x, given that f of x, all right, is equal to x plus 2 over 2 if x is less or equal to 3, and this function is 12 minus 2x over 3 if x is greater than 3. So solution. So this one is pretty much direct, all right? It's pretty much direct. This function, that's the reference line here, is 3. So what happens when you substitute the value of 3 in this side? You are going to get it 7 over, in this left side, yeah, this side. So this limit, when you substitute the value, it's going to be 3 plus 2, 5 over 2. So this side, you are going to get 5 over 2. What about this other side? This other side, you're going to get 12 minus 6 over 3, you're going to get 2. All right, I I might have done this one in a very rushed form that maybe some of you do not get. So I will just come and say that let's evaluate the right hand side limit, which is going to be limit as x approaches 3 in the positive direction, all right, which is 12 minus 2x over 3. When you substitute this one and evaluate, we're going to get 12 minus 6 over 3, which you're going to get 6 over 3, which you're going to get 2. Then the left hand side limit, you're going to get limit as x approaches 3, but now in the other direction, which is x plus 2 over 2, which this then gives us 5 over 2, all right? So then you conclude, since LHL is not equal to RHL, isn't it? Then f of x has one-sided limits. So that's the test. That's how it's done. So exercise. The question maintains, show whether the following functions have unique or one-sided limits, and you are told its limit as x approaches 2 of f of x, given that f of x is equal to x squared minus 4x plus 6, and this one is, in this condition, x is less than 2, and it is minus x squared plus 4x minus 2, and the condition is x greater than 2. So solution. So kindly pause the video and try to solve this one and see what you're getting before we solve it together. All right, so welcome back. Thank you for trying. So again, you are going to take the left-hand limit. Left-hand limit now, which one is it? The one that is less, right? Because it's 2. Left-hand limit is this one, less here. So its limit as x approaches 2, x squared minus 4x plus 6. What do we get? We get here it's 4 minus 8 plus 6. What do we get? We get 2. All right, then the right hand limit, we get limit as x approaches 2. Now it is minus x squared plus 4x minus 2. What do we get? We get minus 4 plus 8 minus 2. We minus 2. So what are we getting here? We are getting 2 as well, isn't it? So then the conclusion, here is to say that since LHL is equal to RHL, then f of x has a unique limit at 2. Yeah, so that's the conclusion. So that's all concerning this section, and I hope this section is not going to disturb you even in the future. So thank you for watching Star Academia as usual. Remember to subscribe, share, and like these videos. Thank you.